A norm. What is the norm? I'll call this as x q norm. Okay, I don't know. Let me write it as, I'll write it like this. What is this? This is square root of x summation q x, right? See, this will give me a different notion of distance, right? I can use the same distance, let's say from here to Dharwad, right? If you use Euclidean distance, you will get, let's say, 14 kilometers to my house. Then if you use a particular q and measure the distance this way, it will be a different distance, right? Maybe you will get 28, or maybe you will get 2, depending on what q is, right? So, but if you fix q, it's consistent throughout, right? It's a norm. Do you agree? So now, essentially, I can define a new inner product also, not just new norms, right? And this new norm will also induce new it will induce a new norm also, right? Okay. So now the question is, suppose I give you a norm, will it be induced by, how can you say that whether it's induced by an inner product or not? Is it possible? Suppose I give you one norm, is it induced by something else? If that is the case, all that I have to do is basically figure out all possible inner products. That means I know all the norms, right? I covered every norm. But if that is not the case, then it's not enough to identify all the inner products, but also I have to identify all the norms that are not induced by the inner products, right? So think about this. Okay, so that's your homework problem, thinking problem. Yes, any questions? Those were online?
Hello, sir.
Yes.
Sir, we are unable to record today's meeting.
It's okay. I think it's fine. So
Okay.
let's see if I can do it. I also cannot. It's okay. I think. So now you have this, right? So set of all norms, right? You have set of all norms. Okay, so this is your set of all norms induced by inner product, right? Now the question is whether this shaded part, right, whether it covers the entire space or it's a part of it, right? That's the question, right, which you are supposed to think and do some background study and let me know. Okay, now essentially what we have a vector space, we have an inner product, we have a notion of distance. In fact, we have multiple notions of distances. Now I can talk about convergence and so on, right? So let's start with this. Okay, so I'll stick to Rn. Okay, it's true for Cn also. Maybe I'll stick to Cn only. Let you take Vn belong to Cn. I think I'll use K. Okay, so this is Vk belonging to Cn, n-dimensional complex vector space, right? Vk be a sequence of vectors, right? This is a sequence of vectors. How do you get this sequence? You can get this sequence in multiple ways, right? For example, those who know what is gradient descent, each time what I do, I look at the vector vk and look at the function f of v. I move in the direction of the gradient, I'll get a new v, right? Vk will be equal to some function of vk minus 1. So I keep on updating, right? So I'll get a sequence of vectors. Now I have to say whether that vector will converge, right? That means I have to stop my algorithm and that will be my solution, right? Any questions? Okay.